Okay, let's start section 2 of this chapter. We start this section with an example. This example is written here. Magnesium, when it reacts with oxygen, it converts to the magnesium oxide. You have exactly the same reaction in the previous chapter. Okay, so say magnesium burns in oxygen and it produces magnesium oxide. So what happens to the magnesium here? Clearly the magnesium has gained the oxygen, so it becomes MgO. So we say magnesium is oxidized, but we said we have always oxidation and reduction reaction together. If one substance is oxidized, the other reactant must be reduced. So here O2 is reduced to MgO. But how? We says the reduction is losing oxygen. The reduction is gaining the hydrogen. Here you can see it's not clear if O2 has lost the oxygen, has gained the hydrogen. So that's why the scientist has revised the definition of the oxidation and the reduction, and they had the better definition for that based on the transfer of the electron. The definitions are given here. It says if a substance loses electrons during a reaction, it has been oxidized. So oxidation is losing electron. If a substance gains the electron, it has been reduced. So the reduction is gaining the electron. So if you want to know if your substance is oxidized or reduced, you just simply look at the transfer of the electron. If your substance has lost the electron, that substance is oxidized and you have oxidation reaction. If your substance has gained the electron, that substance is reduced and you have reduction reaction. Okay, so to remember that, you can remember oil rig. Okay, so they means oxidation is loss of electrons, reduction is gain of electrons. So oxidation is loss of electrons, reduction is gaining of electrons. So how can this definition helps us in these reactions that we had here earlier? So this is the magnesium atom. You know its electron configuration is 282, and this is the oxygen atom with its electron configuration is 2,6. Oxygen needs to gain 2 electrons to become octet, and the magnesium needs to lose 2 electrons to become octet. So magnesium gives 2 electrons to the oxygens. So what happens to the magnesium? Magnesium is losing oxygen. So we say the magnesium is oxidized. And what happens to the oxygen atom? Oxygen is gaining the electron. So we can say the oxygen here is reduced. So based on this definition, based on the electron transfer, the definition is very clear, and we clearly can say which one is reduced and which reactant is oxidized. So we can divide these type of the reactions into two half equation. In one half equation we can write the oxidation, in another half equation we can write reduction. Okay, we call them half equation because neither of them is complete by its own. Okay, always the oxidation and reduction happens together. So actually the complete redox reaction is sum of these two half equations. Okay, so for the example that we had earlier, the half equations are written here. So what happened to the magnesium? Magnesium is converted to Mg2 plus. You can see here in this picture, when the magnesium loses 2 electron, it becomes Mg2 plus. So the magnesium converts to the Mg2 plus. How? By losing 2 electron. So losing 2 electron, when you have oxidation or losing the electron, electron is written at the right side. It means your compound has lost the electron or your atom has lost the electron. And what happened to the oxygen? The oxygen atom here has gained 2 electrons. So here the O2 or oxygen gained 2 electrons and it becomes O2 minus. Okay. So it's important when the electron appears at the left side, it means your substance or your species has gained the electron, and the reaction which is written here is reduction of equation. And if the electron is written at the right, it means your substance has lost the electron, and what is written here is oxidation of equation. Okay, but these half equations which is written here are not exactly correct, especially this one. You know that in the nature you don't have oxygen atom. What do you have there? You have O2, oxygen molecule. So here you have to write O2. Okay, so it's written here O2 converts to O2 minus, but because here you have two oxygen, you will have two oxygen atom or two oxide at the right side, not oxygen atom, sorry, two oxide at the right side. Okay, so O2 by gaining the electron converts to two oxide anions. Okay, so how many electrons they must gain to convert to 2O2 minus? Each oxide must gain two electrons. So if you have two oxide, there must be four electrons for that. Okay, so this is the correct correct reduction of equation. Okay, but the amount of the electron which is gained here must be same as amount of the electron which is lost here. Otherwise, where the two extra electrons comes from? So that's why you have to multiply this one by 2 to make the number of the electrons equal. So it says the number of the electrons must be same in both equations. So we multiply the first one by 2, it becomes 2mg, gives you 2mg2 plus, and 2 times 2 becomes 4 electron. And for the reduction half equation, you have O2 plus 4 electron to O2 minus. So no, these are correct half equations. Okay, so let's move on, have another example here. So it's the reaction between Na plus Cl2 becomes NaCl. So you can see this is the redox reaction, but you don't have oxygen, you don't have hydrogen. So neither of these reactants gain the oxygen, none of them has lost or lost the oxygen. So how can we say which one is oxidized, which one is reduced? The new definition based on the transfer of the electron. You have to look here and check which of these reactants has lost the electron, which has gained the electron. The one which is lost the electron is oxidized, and the other one which gains the electron is reduced. But how we can know? Okay, so what do you have here? Here you have sodium, and here you have chlorine. But what is the product? Sodium chloride. You know that the sodium chloride is an ionic compound. The ionic compounds composed of the cation and anion. But why we don't have the charge here? Because the positive and negative charge cancel out each other. So instead of writing NaCl solid, you can write Na plus Cl minus, because you know it's ionic compound and it's composed of the cation and anion. Okay, now you can easily see what's happening here. Actually, the sodium atom has converted to the Na plus. What happens to it? It has lost the electron, so it is oxidized. And what happens to the Cl2? It becomes Cl minus. It has gained the electron, so it is reduced. The rest of what is written here I will explain to you later on. But let's go to the next example. Here, Cl2 reacts with 2KBr, becomes 2KCl plus Br2. Again, how we can say which one is reduced, which one is oxidized? Okay, so there are two ionic compounds here, KBr and KCl. It composed of the cation and anion. What is the cation here? K plus. What is the anion here? Bromide, Br minus. What about this one? What is the cation? Same thing, K plus. What is the anion? Cl minus. Okay, now we can easily say what's happening here in this case. You have K plus at the left side, you have same thing, K plus at the right side. So the K plus neither gained the electron nor lost the electron. Let's look at Cl2. Cl2 is converted to the Cl minus, so it has gained the electron. So this one is reduction, converting Cl2 to Cl minus. And what happens to Br minus? Br minus becomes Br2. So this one has lost the electron. This is oxidation. So Br minus becomes Br2. It is oxidation. Okay. Okay, so we have these equations here in your book. It says Na solid plus Cl2 becomes NaCl solid. Okay, this one can be gas. Okay, so they ask us to write oxidation half equation and reduction half equation, and finally they ask us to balance the equation based on this half equation. So what we have to do here, at the right side or at the left side you have sodium and chlorine gas, but at the right side you have NaCl. As I said, this is the ionic compound, so you know that it's composed of the cation and anion. Now I can easily understand which one has lost the electron. Na has lost the electron to Na plus. So this is oxidation. And what happened to the Cl2? Cl2 becomes Cl minus. It has gained the electron. So this one is reduction. So here I write oxidation and reduction half equation. So I write oxidation half equation. I write just EQ. EQ means equation. So oxidation half equation, Na is converted to Na plus. Okay, for now I don't write the symbol here. It's not necessary, but you can write if you like. Okay. Okay, first you have to balance these half equations, but let me write the reduction half equation as well. So reduction half equation. So what you have in reduction half equation, on the left side you have Cl2, it has converted to the Cl minus. Okay, so the next step, you must balance both of these equations. You must balance their mass and you must balance their charge. Okay, what do you mean by the balancing their mass? So look at the left side in this oxidation half equation. How many sodium do you have? You have one. At the right side, how many sodium do you have? You have one sodium. So you have one sodium at the left, one sodium at the right. Okay, here is in the form of the ion, but no matter. You have sodium at the left, you have sodium at the right. What about the charge? You don't have any charge here at the left side. At the right side, you have a positive charge. So the charge at two sides of the equation also must be the same. How you can equalize the charge at the both sides? You can make the charge equal by adding the electron. You must add electron to the side which has extra charge, or the charge is more positive. In this case, you have to add the electron to the right side. But how many electron we must add to make it equal to the left side? If you add just one electron, that would be enough, because this electron is negative and Na plus is positive. They cancel out each other, so the charge at the right side becomes 0, and at the left side is already 0. So now this oxidation half equation is balanced, both their mass and their charge. Let's go to the reduction half equation and see what's happening here. What do you have at the left side? You have Cl2. Okay, you cannot write Cl because Cl is a diatomic in the nature. Okay, so you have to write Cl2. Okay, so we don't write Cl. Okay, what do you have at the right side? You have just one Cl. So if you want to make them equal, you must put the coefficient 2 here. It's like the balancing that we had in previous chapter. Again, no, their mass is balanced. 2 chlorine at the left, 2 chlorine at the right. No, we have to make their charge equal. What is the charge at the left side? The charge is 0. You don't have any charge species. What is the charge at the right side? Okay, you have 2 chloride, Cl minus. Each one of them has negative charge. So 2 negative charge. The charge at the left side is 2 minus. You must make them equal. As I said, you have to add the electron to the side which you have more charge. Here the charge is 0, here the charge is negative 2. So you must add 2 electrons here. If you add 2 electrons, the charge at the left side would be 2 minus or negative 2, same as the right side. So this one is correct reduction half equation. So I rewrite them here. Okay. So for the oxidation half equation, you have Na, it becomes Na plus 1 electron. Okay, the electron must appear at the right side because this is oxidation. As I said, in the oxidation, you always have the electron at the right side. So if you're balancing the oxidation half equation and the electron appears at the left side, you must know that you have done something wrong. Okay, and let's write the reduction half equation. The reduction half equation, Cl2 converts to Cl2 plus 2 electrons that we have here converts to 2 Cl minus. Okay, so we have to add these two equations to get a redox reaction. But as I said earlier, the number of the electron must be equal. Here, the Na has lost 1 electron. Here it has gained 2 electrons. So where that electrons come from? Actually, you have to multiply these one by 2. So if you multiply all of them by 2, you have 2 sodium. It becomes 2 Na plus, and instead of the 1, it becomes 2 electron. Now you can see that the number of electron here is 2, and for the reduction is 2. So now you can add them. Okay, so how we can add them? You have 2 electron here at the left, here 2 electron at the right, so they cancel out each other. Okay, so the rest of the substance, they cannot cancel out each other, so you just write them. So it becomes 2 Na plus Cl2, it becomes 2 Na plus 2 Cl minus. So this is the correct redox reaction. Okay, so let's go to another example that you had in your book, and that is the reaction of, okay, let's look at your book. That is the reaction, oops, okay, Cl2 and KBr. So Cl2 reacts with KBr, they convert to KCl and Br2. Okay, so here we go to the same step that we had earlier. So I show it for you. Here you have Cl2, it's a molecular compound. Here you have KBr, ionic compound. It means you have K plus and Br minus. Here you have KCl, it means you have K plus and Cl minus. And here you have Br2 is molecular compound. So molecular compound, you cannot separate it to cation and anion because they don't have cation and anion. Now identify the species which has gained the electron and the species which has lost the electron. Cl2 becomes Cl minus. So it gained the electron, it is reduction. And Br minus becomes Br2. It has lost the electron, this is oxidation. So here I write oxidation half equation, and reduction half equation. So in the oxidation half equation, Br minus is converted to Br2. And in the reduction half equation, Cl2 is converted to Cl minus. Okay, so let's balance each one of them. Let's start first with the oxidation half equation. Okay, you have one Br minus at the left, but two Br at the right side. So I need to put two here. Okay. Now the mass is balanced. Let's balance the charge. What is the total charge at the left side? 2 negative. So it's 2 minus 2. At the right side, you don't have any charge, so you need to add 2 electrons to make the charge at the right side same as the charge at the left side. Now this one is balanced. Let's go to the reduction half equation. You have 2 color in here, but 1 color in here. So I add 2 here. No, their mass is balanced. But what about the charge? What is the total charge at the right side? Negative 2. 2 times 1 becomes negative 2. Total charge at the left side is 0. So we add the electron here. How many electrons we must add here to becomes negative 2? Yeah, as you guess, we must add 2 electrons. So now both of the equation is balanced based on their mass and their charge. So in this case, we have to check if the number of the electron which is lost in oxidation is same as the number of electron which is gained in reduction. 2 electron here, 2 electron here. So yeah, they are same. So we can just simply add them. When we are adding them, these 2 electron at the left side for the reduction, cancel these 2 electron at the right side for the oxidation. The rest of the substance, they cannot cancel out each other. You can cancel them if they are exactly the same. Okay, so at the left side you will have 2 Br minus plus Cl2 here, and at the right side you have Br2 plus 2 Cl minus. So this is the redox equation. Let's go back to your book. Okay, so what is written here I have explained to you in just right now. So in the summary it says oxidation is gain of oxygen or lose of electrons, or what was another definition? Lose of hydrogen. And what is the reduction? Reduction is loss of oxygen, gain of electrons, or what? Gain of hydrogen. So, and as we said, oxidation and reduction always take place together, so that's why we call them redox reaction. Okay, same as previous video, you can check these questions, try to answer them, especially this one, okay, and check if you can answer that one or not. So in the next video that I will upload later, I will give you the answer for the questions in section 1 and section 2.